In this video, we will tune a system using the FFT chart graphing feature of the ideal ATL client. To begin, the tuning gains must be initialized to the proper values. In this case, the system is a 1291 LX, and the values I have shown in the terminal here have proven to be a good starting point for this tuning method. Next, we'll want to open a graph panel, and we'll do that by going to View, Add Panel, and Graph. We'll want to verify we are using the FFT chart, and we want to lock frequency range from 0.01 to 200 Hertz, and our sample frequency is 20,000. Next, we want to choose the chart register we want to watch, and that is the position error register. Okay, now we want to set up a rate. And in our case, we will jog the table at 360 degrees per second. So I will move the terminal panel over here to a jog 360. All right, let's start the graph and see what's happening. And let's just give it a cycle or two to stabilize. All right, so you can see there are position error spikes all along the different frequencies. Our goal here is to shrink the position error spikes as small as we can, which will increase the accuracy of the table. On the 1291 BLX, if most position error spikes are below around 0.0001, the table will generally meet the rate stability spec. But before we start tuning the system, there are a couple of things to note. The two values we will be changing in this video are FVE, or the velocity feed-forward gain, and the position loop pro, or proportional gain. An important reminder is to make sure the pro we are changing is in fact the position loop one. So to ensure this, let's move into the position loop with the command CLS, or control loop select, CLS, and we'll give it a P for position loop. Another thing to consider is when changing the value of FVE or Pro is to not let the two values get too far apart from one another. For example, if you see increasing FVE is having a noticeable effect on the position error, avoid continually increasing it without occasionally increasing Pro as well. If the two values get too far apart from one another, the system tuning can become unstable. Now that those caveats are out of the way, let's start tuning the system. Let's start with FVE. Our initial value is 0.01, so let's increase it to 0.02. At about 0.015. And as you can see, the position error spikes have started to get smaller. So let's keep going. 0.03. We'll give it a cycle or so to stabilize. There we go. And we're still getting smaller. 0.04. About 0.0003 now. And it's still going down, but to avoid Pro and FVE getting too far apart, let's add some Pro. So our initial Pro value is 10, so let's increase it to 15. And about 0.003. So, and it looks like it's still getting smaller. Keep increasing Pro. Let's do Pro 20. Still getting smaller. Go Pro 25. 25. And I mentioned at the beginning of the video that if most position error spikes are below 0.0001, the table will pass a rate stability test. And as you can see, we are about within that spec, but let's see how small we can make these spikes. Let's increase B again. Get a little more cycle to stabilize. All right, go on FFT 0.06. A little bit of a change, but not much. Let's try Pro. Pro. Wait for this to update. Okay, now we're getting smaller. Pro 35. One more cycle. Looks pretty close. That looks pretty good. Right here. So I think that's about as small as I can make these spikes. And after that, it looks like we are all done. And that's all there is to it. If all you need the system tune for is rates, then we are done tuning. And let's not forget to save the package so we can keep this tuning. So let us stop it and turn the servo off. And we will call our package FFT rates. So we will save it with the PKS command and we'll do FFT rates. And so if we list our packages, it's our new package, FFT rates. If the system will be used for positioning as well, check out our video on tuning for step response. This concludes our video on tuning for rates using the FFT chart method. Thank you for watching.